Hello, ladies and gentlemen. We are doing lesson 4 today, Conic's form of a parabola, writing equations. And I already did the warm-up, so I'm going to kind of push it here for a minute, because what I want you to do in a second is to do that warm-up without me. But let me go back to where we were in lesson 3, is that I gave you, for the problems in lesson 3, I gave you the formulas, right? So we gave you formulas, and then I had you provide me with the information from that formula. So the vertex, the focus, the directrix, open it up, down, left, right. And then we even did some, remember we had to do completing the square in order to get it in that format. So remember all that from the other day? So I want you to take a minute without looking, I'm not even going to show you, without looking at anything. I want you to try and do that warm-up on the lesson 4, those first two. Okay, so I want you to pause the video right now and try that. Okay, so you should have paused and you should have tried warm-ups A and B, and you should have gotten this information. So let me show you what I got. So B, what you had to do is you had to put it in conic form. Okay, so B, if you can see over here, let me go a little bit narrower. So B, what I did was I did the completing the square process in order to put it in that format. And then what you determined was that it had a vertex of -2, -3, a p-value of 1. You did a graph, right? You got the domain, the range, and then I don't want to ignore the A just because it's already in that format, but that was opening left, and it was opening left because it was a -8, right? The p-value is 2. Remember I said the p-value is always absolute values of just the measurement, so 2. And then you could do the focus and the directrix from there. Okay? All right, so now we get to the good stuff. So now we're going to use the information given to derive the equation of a parabola. So I have a vertex, I have a focus, okay? So I'm obviously always going to give you some pieces of it. So remember how we started on that first day where I had said to you guys, make sure that you graph, like just do a little plot. So when x is 2 and y is -3, I have a v for vertex. And then when x is 2, oops, I didn't get on there. And x is 1, 2, 3, 4, 5, I have a focus. So I know right now that I have a quadratic that is going to face downward, right? So either going opening up or opening down, that's going to be an x squared. In fact, actually, let me go back, because I was actually thinking of doing this before. Is that, remember, these are the two formulas that you have to have in your noggin. And it's where the h and the k is the vertex. So it's either going to be an x minus h squared, or it's going to be a y minus k squared. And if it's a y minus k squared, then that opens left or right. If it's an x minus h squared, it opens up or down. It opens up if this 4p is a positive. It opens down if the 4p is negative. For the y minus k squared, if the 4p is positive, it opens to the right. If it's negative, it opens to the left. So this one is going to be definitely this formula, right, where that 4p is going down. So it's negative. I should say it's negative. Okay, so remember, your vertex is your h and your k. So you're going to do x minus 2 squared equals, okay, now what's the p? Remember, the p is that measurement right here from the vertex to the focus. So I see a measurement of 2, right? Or the directrix, we didn't even need the directrix, but the directrix would be 2 above. So it's equidistance. That vertex is equidistance from the focus as it is from the directrix. Means equally the same distance. Okay, so anyway, back to the p. So I've got a p-value of 2, so 2 times 4 is 8. But because it opens downward, we're going to make it a negative. And then at y minus k, which turns to a positive 3, because when I put the negative 3 in, the two negatives make a positive. So there's my equation. Okay, let's try another one. Let's change the color. Why not? All right, so for this one, I've got two, you know what, I can tell right now, I'm not going to have enough space. 1, 2, 3, 4, 5. 2, 3, 4. So I got 2, 4 is the vertex. 5 is the x equals 5, right? So 2, 4, and then x equals 5. That means that, and I've got the focus on the other side, right? So it's opening to the left, which means if it's a left right, it's a y squared. Because it opens to the left, it is a negative, right? 4p will be negative. And the p-value is that distance again between the directrix right in here. So there's your p, which will be 3. Okay, so I've got p equals 3. I already have my h and my k, and I know it opens left, so it will be a negative. Okay, just plug it in now. Remember, be careful here. Y minus 4, not y minus 2. The 4, that 4 goes with the y. The 2 goes with the x. Okay, so p is 3, so 3 times 4 is 12. Make it that negative, don't forget. And I've got x minus 2. And there's my equation. So if you know all the parts over the last couple of days, like this part, this is not really that hard. It's just that you gotta remember all that. So I'm gonna put those formulas up on the top again, just so we have them. I think it's good. I hope I don't drive you guys crazy, but I just love to change the colors up. It keeps it going. Keeps it exciting. 4p minus k, and then I got y minus k squared equals 4p x minus h. Okay, so for this one, use the information given to find the set of points that are equidistant from a point, negative 3, 4, and the line y equals 2. Okay, now this sounds really different, and it's really not. Use the information given to find the set of points that are equidistant from a point and a line. The point, peoples, is a focus. The line is a directrix. So when they say to you, find the points, the set of points that are equidistant, that means I am dealing with a parabola. I am dealing with a parabola because all those points on a parabola, remember, are all the points that are equally the same distance from the focus, a point, and the line, the directrix. So they're asking me just to create a parabola. That's it. It's a fancy way for saying, hey, write a parabola. That's all. Okay? So I've got negative 3, 1, 2, 3, 1, 2, 3, 4 is my focus, right? Y equals 2 is my directrix. So if this is 4 and this is 2, that means my vertex has got to be somewhere here, which that means that is, right, negative 3 and 3. So my vertex is negative 3, 3. You can see that. Can you see it okay? Right? So that means it has a distance, a p-value of 1. So p equals 1. Okay? So it opens up. So it's going to be an x squared, and it's going to be positive, right, because it opens up. All right, so I'm going to be using this formula, this x minus h. Okay, so remember my vertex is negative 3, 3, so this is my h, this is my k. X plus 3 squared equals, okay, 4p. The p is 1, so 4 times 1 is 4 with a negative in the front. Not a negative. Mrs. Reach, you're wrong. It's a positive because it opens up. And a y minus 3. Okay? All right, so if they ask you that question, and we may ask you that question on a checkpoint and on a test, because I've seen it before, you want to make sure you're comfortable with it. Did we create, okay, think about what the question said, use the information given to find the set of points of an that are equidistant from the points, okay? Use the information given to find the set of points that are equidistant from the point negative 3, 4, and y equals 2, which we did. This equation represents all of those points, every single point on that parabola that is equally the same distance from that negative 3, 4, and y equals 2. So we created all the points. We have an equation that represents all the points. It's probably the best way to say it. Okay? All right. All right, so now the directrix of the parabola is y equals 0. Find the coordinates of the focus of the parabola. Okay, so what have I been telling you to do? Just draw a little sketch every single time. It's really as simple as that. Okay, this is just going back to some of the stuff that this is just because we did enough with the like we create an equation. I kind of figured maybe we just break it up a little bit. So these last ones, yeah, you don't have to come up with an equation. They gave you an equation, but they're different formats of the question. All right, so I do know, remember from yesterday, I have negative 2, 3 is my v, this is my h, and this is my k. So negative 2, 1, 2, 3 is my v. Y equals 0. So this is actually on the x-axis, the y equals 0. Okay, so if I have a point here, and that y equals 0 is my directrix, so that means it's going to open like that, right? Or something to that effect. So I've got a difference of 1, 2, 3. So that means 4, 5, and 6 is going to bring me up to the focus. Okay? So it's still going to be over negative 2 because they're all lined up. So my focus is negative 2, 6. And that's all they wanted for that one. Again, you're just drawing pictures. Like, that's all I expect you to do. Just draw a little sketch. If you know all the pieces, it can be easy to find. I mean, there's formulas that, like, I could say, but if you can do a sketch, that's it. That's all you need. That's all I'm asking. Okay. Which of the following equation is equivalent to the Conic's form shown above? All right. Now, this is where it really is different, and we've seen a lot of questions like this. I got to write this, so this is what I'm going to do. I'm going to bring it down here. And that formula that's above is x plus 2 squared equals 12 y minus 3. So we've seen this quite a bit on the Regents, actually, where they say, okay, here's your conic formula. They give you the directrix and the focus. And then they say, which of those is equivalent to that? Well, those, in part B, these multiple choice questions or answers, are in the form of a different format. It's called vertex form, which we'll talk about tomorrow. is a different format than the conic form. So I basically, if you look, they're all solved for y. See them? They all say y equals. So I have to come over here to my formula and I have to solve for y then. So the first thing that I'm going to do is, instead of distributing, because I know your first thought sometimes is to distribute a 12 through to get rid of the parentheses, I wouldn't do that. The 12 is being multiplied by the y minus 3, right? It's like literally there's a multiplication symbol there. So I'm going to divide that 12 out, and I'm not going to put it through here. I'm actually going to bring it on the outside. See how I did that? So I divided the 12 out, which actually creates a 1/12 over here. Okay, because I can't distribute it through this set of parentheses either. I want that, because if I did that, I couldn't distribute it through that x plus 2 anyways, because I got a squared. I'd have to do order of operations. So I'm just going to make that 12 on the one side. When I divide it out, it becomes a 1/12 on the other side. Okay? There's another way, which I'll show you next. I'll show you tomorrow when we do a problem. I don't think I have any more. Like that. Oh yeah, I do have one I can show you. Well, not really. I'll show it to you tomorrow. I got an idea, another formula way to show you that. Okay. Anyway, so I got rid of the number in front of the parentheses, so I really don't need that parentheses, those sets of parentheses anymore. And then I'm just going to add the 3. Again, I'm not distributing anything on this side. Right? I'm not going to get rid of the exponent of the squared. I'm just going to leave it like that. And when you look and compare, I definitely see an answer with that. Okay? All right, so a little different format than you're used to. All right, so last problem of the day, okay, is 4. So when we look at 4, it says write the equation. Okay, there's my equation. In Conic's form, identify the vertex and the p-value. So I see an x squared. So I know my conic form that they're referring to is got to be this, right? But right now, I don't have it in that form. I actually have a 4 in the front, and I have this -8 y parentheses y minus 4 is like on the same side. So we need to get rid of, this is what I would do first. I would get rid of that -8 parentheses y minus 4. And it's basically subtracting, right? So I would do the opposite. I would add, right? I'm going to literally add the whole thing to the other side. So when I do that, I end up with 4 parentheses x plus 2 squared equals a +8 parentheses y minus 4. Because you can think of this as all one big glob of multiplication there, right? One big piece. The -8 times the y minus 4, I can add the whole thing over to the other side, okay? So I'm almost there. If you compare it to what's up here right now, the only big difference is I have this 4 here, right? Now the 4 is being multiplied. Undo multiplication by division. So I'm going to divide out the 4. When I divide out the 4, I can just, because it's separated, that the y minus 4 is separated in parentheses, I can just do 8 divided by 4 here. So these cancel out. And then I've got an x plus 2 squared equals 8 divided by 4 is 2 y minus 4. Okay. And it says identify the vertex and the p-value. So the vertex is -2, 4. And the P, okay, now remember this from the other day. The P value, this whole thing right here is 4P. So, and this 4P right now is 2 here. So if you're not sure what P is, set 4P equal to 2, because I know whatever is here is the P value times 4. So I'm going to say, okay, I'm going to say 2 is equivalent to 4P, and I'm going to solve for P, so P must equal 1/2. So P is equal to 1/2. Okay? All right, so now they want me to take the equation, write the equation in standard form. All right, so now remember, I have all this information, right? I have it in conic form, like this. They want me to put it in standard form of ax squared plus bx plus c. So I would imagine that I'm just thinking about, okay. I would imagine that what you guys probably would do would be to just go straight out and distribute that. Because when you put it in standard form, you have got to solve for y. So that's my guess, is that you guys would do that first. And then remember, x plus 2 squared, I taught you this in the last unit. It's one of the reasons why we went over it. Is that you got to remember that x plus 2 squared is x plus 2 times x plus 2. I'm sorry, but this is messy. I gotta fix that. And then you do your distribution properties. So double distribution, area model, x times x is x squared. I got x times 2 is 2x. I got another 2x. That's going to be 4x plus 4 equals 2y minus 8. Almost there. Add the 8. I got an x squared plus 4x plus 12 equals 2y, and then you would divide everything, because there's no, like, it's not like this one up here that we divide out just the front part. You have to divide all of them because they're all distributed. So I got a 1 here. This ends up to be a 1/2, because 1 divided by 2 is 1/2. 4 divided by 2 is 2. 12 divided by 2 is 6. And there is my answer. So it does say, write the equation in standard form, find the vertex using the table in your calculator. So you would go to put this in your calculator, and you would see that when you go to the vertex of -2, 4, you would see symmetry on each side. I'm going to explain that a little bit more tomorrow when we do our other lesson. Okay? All right, guys, you have a good night, or good afternoon, depending on when you're watching this, or good morning. And I will see you on the next video. Okay? Make sure you do the homework for this. Okay? It's in your homework packet, and I don't believe I'm making you, you're just going to show it to me on Monday or on Wednesday if you're group B. Okay? So you don't have to send me pictures for these. Okay? But make sure the homework gets done. Definitely has to get done for this. This is lesson 4. Make sure it gets done. Okay? Talk to you soon. Bye.